Hello, welcome to this video. So this MC question is about the manipulation of complex numbers. Okay, so first of all, okay, so we have W equals alpha plus I over alpha minus I. Okay, so you can see we have I okay in the denominator. So of course, okay, we need to do the rationalization. And then for the denominators, okay, so that will be alpha squared minus I squared. So that's why alpha squared minus -1, we can replace I squared by -1 here. And then for the numerator, so that will be alpha plus I times alpha plus I. So that will be the perfect square. So that will be A squared plus 2AB plus B squared. So I squared is -1. And then simplify a little bit, so that will be alpha squared minus 1 over alpha squared plus 1. That will be the real part, and then the imaginary part, so there will be 2 alpha over alpha squared plus 1 I. Okay, so that will be W. So and then 1 over W, so that will be just alpha minus I over alpha plus I. And then using similar technique, but this time, okay, we try to do the rationalization by multiplying the original fraction by alpha minus I over alpha minus I. Denominator similarly, so we replace I squared by -1. But numerator this time, so that will be the perfect square, the square of alpha minus 1. Okay, so that will be A squared minus 2AB plus B squared. So I squared is -1. So that's why here, okay, so that will be alpha squared minus 1 over alpha squared plus 1 minus 2 alpha over alpha squared plus 1. I. So and then we got W and 1 over W. So we go back to statement 1. So U is a real number. So U, okay, equals to W plus 1 over W. So here, okay, I'm afraid, okay, so we can do similar to equations, the method of eliminations, okay, in doing the solving of simultaneous equations. Okay, so here we try to look at, this is what we call the equation 1, and this is what we call the equation 2. Okay, so and then to sum them up, because U is about sum them up, so sum them up, so we can see that, the imaginary parts, okay, will be cancelled because, okay, the imaginary parts, okay, are the same but with opposite signs. Okay, so that's why here U, okay, will be 2 times alpha squared minus 1 over alpha squared plus 1. Okay, and then which is real. Okay, because A, okay, or alpha, okay, is also real. Okay, because alpha is real, so of course after and then you can see this fraction, okay, contains no I, so that's why this fraction, okay, will be real, so that's why U is real. That's why statement 1 is correct. Statement 2, so the real part of V is equal to 0, so first of all, V, okay, will be the difference, okay, between the green expressions and the yellow expressions, so that's why in that case, okay, the real part will be cancelled. Okay, so that's why the remaining stuff, okay, will be 4 alpha over alpha squared plus 1 I. So of course, okay, in that case, okay, because you can see V, okay, will be, well, just contain the imaginary parts. So of course, okay, the real part of V, okay, will be 0. So that's why statement 2 is also correct. Statement 3. So, okay, so we go back to the W, so the imaginary part of W, so imaginary part of W, so that will be this. Imaginary part of W, so that will be this. Okay, so of course, okay, the imaginary part of W, so will be 2 alpha over alpha squared plus 1. And then the imaginary part of 2w. So that will be 4 alpha over alpha squared plus 1. Okay, so because we got the w, the complex number w, in the standard form. So of course, if we got 2w, so maybe we can do it like this. So 2w. So we have yellow then. So 2w, then that will be 2 times the whole thing. So of course, the imaginary part of 2w, will be 4 alpha over alpha squared plus 1. So that's why, you can see that in general, the imaginary part of w is not equals to the imaginary part of 2w. So that's why statement 3 may not be true. So that's why here, maybe a little. That's good. So that's why to sum them up, only statements 1 and 2 are correct. So that's why here, so the correct options here, will be option A. So and then the problem is done. Thank you for watching.